Okay, good day, everyone. Let's solve this problem about magnetic field around a wire. Let's have a 1 meter long wire with a diameter of about 1 millimeter. It's made of some elements called nichrome. You can find the resistivity of the nichrome from any table. It's connected to a battery with 12 volts of electromotive force. And we want to know what is the magnetic field about 2 centimeters away from the wire. Okay, so here is a pictorial diagram. We have this wire with surface cross-section area, which is a disk. The current is created inside it because of the battery, and we want to know what is the magnetic field at this point, 2 centimeters away from this wire. Now, the first thing is I need to know how to model a magnetic field around this wire. So I would say since 2 centimeters is much, much smaller than 1 meter, which is 100 centimeter long wire. So I can conclude that I can model this wire as if it's infinitely long wire, which means the magnetic field around wire would be approximately mu0 divided by 2 pi, the current which passes through the wire, divided by how far away we are from the wire. Okay, that's the modeling. So in this case, if I know what is the current, and if I know where I want to know the magnetic field, then I can calculate the magnetic field. But because this is a wire with some resistance R connected to a battery with electromotive force of 12, if I know what the R is, then I can calculate what is the current inside this wire. So the electromotive force of the battery minus the current times the resistance of the wire would be equal to 0. That's our Kirchhoff loop's law. So from here, I can calculate what is the current. It would be electromotive force of the battery divided by the resistance. So electromotive force of the battery is given to be 12 volt. If I know what is the resistance of the wire, then I can calculate the current. Okay, the resistance of the current is a function of the property of the wire, the resistivity, the length of the wire divided by the cross-section area of the wire. Now, if you open any textbook and ask what is the resistivity of nichrome, it would tell you that it's 1.50 times 10 to the power minus 6 ohm meter. The length of the wire here is 1 meter. And the surface area, the cross-section area, is a disk. So it would be pi r squared. I will have the diameter, so I can calculate the radius, or I can directly say it's pi divided by pi times diameter divided by 2 to the power of 2. Now let's insert the numbers into the equations and find what is the resistance of this resistors. So rho is 1.50 times 10 to the power minus 6 ohm meter divided by pi divided by 4 times 10 to the power of minus 3 to the power of 2. The diameter is 1 millimeter. 1 millimeter is time 10 to the power minus 3 meters. multiplied by L, which is 1 meter. So 10 to the power of minus 3 to the power of 2 will give me 10 to the power minus 6 meters, 10 to the power of 6 meters, and 10 to the power of 6 meters cancels. The unit also cancels. This is meter square. One of them cancels this meter. One of them cancels this meter. And then we have 4 multiplied by 1.5, which gives me 6.0, divided by pi, and the unit would be ohm. Okay, so that's the resistance of our wire. Now let's go and replace this into this equation. So we have 12-volt battery divided by 6.0 divided by pi, or, and this would give me the current would be 2L divided by 6.0 divided by pi. This becomes 2 pi, and the unit would be amp, or volt per. Okay, so this is the current which passes through this wire. And now if I have the current, I can plug into this equation and calculate the magnetic field. Okay, so let's just do it. So we found that current is 2 pi. So let me just repeat the equation here. So I will have the magnetic field of the wire to be equal to mu0 is the permeability of the vacuum. Permeability of the vacuum is 4 pi times 10 to the power minus 7 Tesla meter per A, divided by 2 pi times current in amp divided by radius in meters. You want to know when R is equal to 2 centimeters, which is 0.02 meters, or if you like, you can write it as 2 divided by 100 meters. And when current is 2 pi ampere, want to know how much is the magnetic field. So this becomes 4 pi times 10 to the power minus 7 in SI unit, divided by 2 pi, multiplied by 2 pi for the current, divided by, I'll write 2 divided by 100. So this will simplify this 2 pi cancels this 2 pi. And so we will have 4 pi, this 4 cancels this 2, I will have 2, so I will have 2 pi, and this 100 comes to the numerator, multiplies by 10 to the minus 7, gives me 10 to the power of minus 5 Tesla. So the magnetic field around this wire would be a circular magnetic field like this, which the direction by using your right hand rules, if you put your thumb in the same direction as your current, then 4 fingers will follow the direction of the magnetic field. So if the current is like this, then the magnetic field would be at any point like this. So exactly at the point B here, the magnetic field would be out of the page. So if, for example, you look from the front, if I'm looking from this side, so what I would see is I will have a current which is coming out of the page. So this is current I coming out of the page. And then I will have a magnetic field which is at any distance radially symmetrical. And so at distance r, this magnetic field at this point would be to the left. At this point would be down. At this point below the wire would be to the right. And in the right side of it would be upward. And the magnitude of this magnetic field will be equal to this value we calculated here. 2 pi times 10 to the power minus 5.